students, today's agenda is to check your homework. We're going to be manipulating exponents and you will be able to work on 8.10. Today's students will be able to manipulate exponents in exponential functions to determine growth or decay in different cycles. And let's say that we get a car loan at 6% APR. Remember, this means annual percentage rate. Because we make monthly payments, what we're going to do is, just as before, we are going to divide this 6% by the 12 months that we make our payments, and that's equals to 0.5% each month that we're going to be paying. And in decimal, it is represented as 0.005. And the reason is because remember that to go from percent to decimal, we always go 2 spaces and fill in with zeros in there. Now let's say that our car loan is $12,000. Our loan or function is going to be L of M. This is for loan and for monthly. What we start with, which is 12,000, and of course the company or the lender wants their money back, so 1 times that, that's how much they're getting back, plus the interest, which is 0.005 per month. And remember that that happens because the APR is per year, it would be representing as per year is one out of the 12 months. Okay, when we divide, this is dividing M by 1/12. We put it over 1, and any division of fractions, we multiply across and the answer bounces. Any division of fractions, that's what we do. Multiply across and the answer bounces. Multiply across and the answer bounces. And 1 times 1 is 1. And anything divided by 1 is the same as the same number. We're going to say that L of Y now it's going to be represented as per year. It's going to be 12,000 times the 1.005 to the, okay, again we're trying to figure out per year how much is that, so we're going to put the 12M, and we're going to raise this base for the 12 months basically, so that I know in 1 year how much I'm paying. 1/12 means every month, but then we're trying to figure out for a year. So now let's put that in our calculator. 1.005 to the, remember that the power, it's when I have y to the x or x to the 1 to the power of 12, or to the 12th power. And so this new base, now changing this because 12 months means 1 year, so the new base will be the loan per year. It's going to be the initial point or initial debt times the new base is 1.06177, etc., etc. 77812. You don't need to put all of them. I would suggest a couple of the digits. And instead of, because 12 months represents the 1 year, we just replace it. Once we raise it, we replace it to the y. So basically, what did I do by dividing it by 12? What companies do, divide the interest into the 12 months. That's the interest that we pay each month. But by raising it to the 12 months that we pay, Okay, we're just multiplying by itself times itself 12 times because we pay it 12 times during the year. At the end, in that 1 year, this is what I ended up paying. But wait a minute. Isn't it true that we're supposed to pay once whatever they lent us? And then if we move it, that will be 6%, right? 6%. So that's up to that point. But guess what? These extra digits in here is just extra pennies that the companies are getting from us. By calculating this into months, if we in reality raise it to the months that we pay for that 1 year, they're getting that extra money. And it might not be a lot, but still, you know, they're getting some extra pennies out of our pocket without giving us credit for. So again, what do? The steps are to divide the 6% by the 12. That's equals to 0.5%, which is equals to 0.005. And so we put the initial point. The base is going to be 1 time whatever they're lending us plus the interest in here. And that's going to be to the month. Okay. We can skip this step if you want to go even more directly. We can just say that from month to year, we're going to say that there are 12 months. Right now I'm looking at months. To make it into a year, so all I have to do is raise it to the 12th power because there are 12 months in 1 year. And so in 1 year, once we elevate these to the 12th power for the 12 months that we're paying, we get the new base, but now that's the new rate for the year. And we notice that they're getting extra money from us. They're not just getting the 6%, but a little bit more than that. So basically that's what you're doing today. You're just manipulating the exponents. Okay, now let's say that you have a credit card. Your credit is $1,000 and it's at 18% APR. Again, we're going to divide that by those 18% just because we don't pay every year, but rather every month. We're going to divide by 12. And so that's equals to 1.5%. Okay, each month I'm paying 1.5%. In decimal form, that's equals to 0.015. Okay, I just went 2 spaces back. All the time 2 spaces. I could put L for loan or D for debt. My debt per month is equals to the initial point, which is 1,000, times 1 time the 1,000 that I have to give back, plus the interest, which is 0.15, and that's per month. Again, you can, well, let me write the next step, but you can just skip this step. D of M, 1.015 to the months over the cycle, which is, if you recall, dividing this M by 1/12, put it over 1. Another way that they do it when we divide fractions is to make it into a multiplication and do the reciprocal of this. Okay, for those who know how to do it this way, we switch, this becomes multiplication, this becomes the reciprocal, and we just multiply straight. So 12 times M is 12M, 1 times 1 is 1, which we never put as denominator, and so it's just as 12M, okay? So we can say that D of Y, because we're talking about the 12 months, D of Y is equals to 1.015 to the now 12 months. Remember that 12 months is the year. That's why we're talking about now into years. And so what is it in reality that they're charging me in that 1 year? So my d of y is equals to 1,000. And this is the part that people get confused. Okay, what do I have to do about those numbers? All you're doing is just raising this base to that power, okay? Raising 1.015 to the power of 12, or to the 12th power, equals 1.9, and I shouldn't write this right here so that I have enough space for everything. Okay, so the new base is 1.19561817, etc., etc., etc. Okay, if you put 4 digits, that's enough for me. But I want you to know that, okay, look at this. They told me in my paperwork when I was signing for this credit that I was gonna be charged 18% annual. But my annual rate in reality is 19, because this is the 1,000, right? But this is the percent that I'm being charged. So they're charging me 19.568, etc., etc., etc. percent. So what are they doing? Instead of charging me 18%, they're charging me 19.5618, etc., etc. percent. So they got money from me of 1.56%, more than that actually. 1.56, 18, 17, etc., etc. percent more than what they told me in the paperwork. So if you notice, we're paying more than what they're saying. Not only are we giving them that in interest, but an additional that is not really in paperwork. If you notice, going from months to years, it goes up. So now what's going to happen when we go from years to months? Well, another example, let's say there is 5,000 people in town. There is an annual growth of 5%. Well, in here it's just annual growth, so it's gonna be, if it's 5%, then we're gonna go back 2 spaces. Now this, we don't say, oh, for now we're not gonna say, oh, we're gonna divide it by 12 months because we are gonna make growth in like every month. Not yet. We're not talking about that. So we're not dividing by 12. All we're doing is moving the space, and it's gonna be 0.05. 5% is the same as 0.05 in decimal form. So what that means is that my population per year is equals to the initial point, which is 5,000, multiplied by the population that exists right now, plus the growth that happens each year, right? In a month, how much growth is there? And what is the purpose of knowing in a month? Well, maybe a governor has to report something for taxes on relation to population, so maybe they have to do the reports every month. And so what do? All you have to do is divide by 12, right? If we're talking about a year, to know in a month, we divide by 12. What this means is, if you think of this as 1/12, because if there's a coefficient, then we say that's equals to 1/12 of y, right? So our P of y is equals to the 5,000 times 1.05 to the 1/12 y, meaning of the year 1/12, right? that represents 1 month. We're trying to change these to months. And so we're going to raise this base to this power to give us population per month. And so it's gonna be, notice how we're just trying to manipulate this. We're not working in reality with the population, okay? But we wanna know what happens each month. So we're gonna say that it's gonna be 1.05 to the power of, in here we're gonna open a parenthesis, put a 1, divide by 12, and then we close the parenthesis and hit equal. Okay, so now our growth is 1.00407, etc., etc., etc. Okay, and that's per month because we're applying this already here. Now that's per month. Let's see, if we're not thinking of it as percent, we just move it twice. It's gonna be 0.407, etc., etc., right? That's the monthly growth in decimal. In percent, okay? So what does that mean? That my percent, if I multiply it by 12, is gonna give me equal to, let me see, 0.407 times 12 gives me 4.884. So basically this is the percent growing if we go from year to month. So what happens? That means that I'm not reporting the complete growth. If I'm reporting in months, then I'm not reporting every person who was born or moved into that town, okay? I'm reporting only 4.8% of that, when in reality it should be 5%. Okay, so what happened here? When we're going from months to years, we raise the base to 12, to the 12 months, okay? When we're going from year to month, we raise the base to 1/12. From year to month, 1 month is 1/12 of a year. That's why we raise this base to this power. And we notice that what happens because of that, in reality, we're not getting a complete 5%. In the other one, when we're going from months to years, in reality, we're paying more than that percent. So from month to year, the percent is greater in reality. From year to month, the percentage is smaller in reality. Okay? So hopefully this was not too confusing. And if you feel that you need to review, you can go ahead and watch the video once again. And well, now you can work on 8.10.